Hello and welcome to SudoKanard. We are here to solve this fortress Sudoku by this Thai author. This puzzle was featured in the recent WPF Sudoku Grand Prix. It was the highest pointer in the round, although I think it was not the hardest puzzle. I usually skip fortress puzzles during the contest, but I attempted this one because it seemed feasible, and actually I almost finished it, except I made the usual canard mistake, and I lost, whatever. So the special rule is that whenever you have neighboring cells with one shaded and one unshaded, then the bigger digit must be in the shaded cell. So that's it, and the rest is Sudoku. So here you see that something you must keep in mind with fortress is that you can never have a 9 in an unshaded cell when it's next to a shaded cell, because 9 will always be bigger. So in this central box, 9 will be in the middle. And then you see that 8 can't be in those cells because 8 can't be surrounded by two bigger digits. So 8 will be somewhere in the corner. And an important fact about this is that wherever you put the 8, the both shaded neighbors must be 9s. So you will have 9s here, or here, or here, and here. Something else is you can see that on this row, 9 can't be in any of those cells because they have a bigger neighbor. So 9 on this row will have to be here, and the same is happening here. 9 can never be next to a shaded cell, in an unshaded cell, so 9 must be here. Now looking at this region, 9 won't be here, it won't be here, so 9 will be somewhere here. And similarly, because of this 9, we don't have 9 here. 9 can't be in an unshaded cell. It must be in a shaded cell here. And something, well, in this box, 9 can't be here. Because there's a 9 here, 9 can't be here, so we have the 9 here. And then we have the 9 somewhere here. In this box, it's the same. 9 can't be next to the shaded cell, so it must be here. And it can't be here because there's a 9 in one of those two cells. And now the remaining 9 is somewhere here. And as I mentioned earlier, the position of 8 will disambiguate all of that. So here we have 6, 7, 8, but this digit here is bigger than both of those, so it must be the 8. Here we have 5, 2, and 1, and for the same reason, 5 goes here. And then, where do we look? That's the question. So where do we look? A valid question could be the place of 8 in such a column, because 8 could be next to a 9, but 8 can't be here. Well, 8 could be here, but it couldn't be here by Sudoku or just by the fact that this should be bigger than 8. Here we would have 2 digits bigger than 8. That's not possible. Here, the same. Here, it would require a 9 somewhere here. 8 here would work with a 9. Yes, it could. So that's something possible. And actually in this region, so 8 could be here, 8 could be here, and 8 could be here, but it couldn't be here next to a shaded cell. So that's it. And an interesting point here is that 8 can't be here. It can't be here. It can't be here because of this 8. So on this row, 8 has to be somewhere here. But because this can't be a 9, 8 can't be here, so we get an 8 here. Now in this region, so 8 is not here because of this, or for the same reason. It can't be surrounded by two bigger digits. 8 here would need a bigger digit here, which is not available, so 8 is here. Now we must have 8 somewhere in here, but it will be next to a 9, and only one bigger digit is available, so the only place is here, 8 with 9 there, so that's not 8. I have the 9 up there, and now 8 here is not possible because it would require a 9 there, so 8 goes here, and that's a 9. So now that's not 9, so we get the 9 here. 8 is not here, but 8 is still possible in this position. Alright, so what about the box up there? 8 here. So 8 can't be here. It can't be here just by the rules of Sudoku. So we are left with 3 places for 8 up there. But in this region, it's different because of those 8s, only 2 places remain, but here I will need a 9 there, so 8 is actually here. So we're left with 2 options for the position of 8s. Where do we look next? It's often useful to look at digit 1 because 1 can never be in a shaded cell except in such a position where it's not neighboring an unshaded cell. So this here could very well be a 1. But in this region, 1 can't be here, it can't be here. Well, it leaves 5 options. But in this area, we know that 1 is not in the corner, so 1 will have to be somewhere here. So that in this column, 1 will have to be somewhere here, which is not so interesting, if you ask me. So where else should we look? On this row, so we have here 1 or 2. Where is the second 1 or 2? This will never be a 1, it will never be a 2. Actually, if you look closely, you see that only 6 and 7 are available here, are valid here. 2 will never work in such a cell, 1 neither does 1. So the second 1 or 2 is here. And those are from 3, 6, and 7, which is interesting because wherever I put the 3, this 3 must have neighbors from 1 and 2. So there must be a 1 or 2 somewhere here, which will complement this one. So if this is 3, then those must be 1 and 2. If this is 3, then this must be a 2, this must be a 1, which is completely possible at this point. Now, so we know that the 2 digits from 1 and 2 are in those cells. There's a 4 here, so this must be from 5, 6, 7. And that's interesting because this digit must be bigger than that, so it must be at least a 6, but there's a 6 here, so this is from 7, 8. Oh, and by the way, where is the second 1 or 2 here? So this could be a 1. This could definitely be a 2. This would never be a 1 or a 2 because the 1 is obviously impossible, but a 2 here would require a 1 there, which would clash. So this is not 1 or 2, that's not a 3. So this is at least 4. So the second one or 2 could be here, it could be here. So that's not so definite at this point. Perhaps I should look elsewhere. So where should I look? What about 7 here? So 7 is nowhere in here. Well, that doesn't seem so useful. Oh, I'm seeing this 7, so I can remove this 7 option. 4 is not here. I remember being more fluent during the contest, somewhat. So where should I look next? So 3 here would put the 2, the 1, and then it would totally work. This is a real Bobbins moment. What options are left here? 2, 3, and 7 only. So what about digit 2 in this area? 2 is not in here. 2 couldn't be here with a 1 there because of that. 2 could be here. 2 could be anywhere in here. No, anywhere in here. So the options for 2 are here, here, and here. In this column, I'm thinking 2 couldn't be here because of this. 2 couldn't be here because 2 smaller neighbors are not possible. 2 could be here. So in this column, 2 is either here or there. That doesn't seem to be so useful. I'm missing something that I found quicker during my attempt. Where does 3 go? Well, any place looks possible at this point. And where does 1 go in this area? So that's the easy stuff I'm missing. Well, 1 is not here. It can't be in the shaded cells, so 1 must be here. So I can remove both options here and put the 1 there. Then it resolves all of that. And then what? Then the 3 is still valid in both places with a 2 somewhere in here. Oh, no, now this interesting point is that because of this 2, 2 is not here, so 2 has to be somewhere here, but in the shaded set it wouldn't work because 1 is not available. So 2 is here, and now this can never be a 3 because there wouldn't be any smaller digit here, and we get the 3 in there. Now there must be a 4 somewhere in here, and those are, this digit is smaller than this one, so it must be from 3, 4, 5, and 6. Well, that's a lot to pencil mark. Those are from 3, 4, 5, and 6. I still need a 1 and a 2 here, but none of them work in this cell, so 1 and 2 are in there. And so this is not 1, 2, 3, 4. This is not an 8 either. So this must be from 5 and 7. That's correct. And because of this 7, 7 will be in one of those 2 cells. And I can wonder where 7 goes here. 7 would work here, it would work here, but it wouldn't work here because this cell could never be more than 7, and the same happens here with this cell. So only 2 places left for 7 in this box. Let's look at this column. We still need 2, 4, 6, and 7. So this is from 2, 6, and 7, and actually only 2 is possible here. 6 doesn't have 2 bigger digits, and neither does 7. So that's a 2. So here we need 4, 6, and 7. At this point, they all seem to work. 2 is not here anymore, so in this column 2 must be with the 1 up there. And those are from 3, 5, and 7. This can be basically anything. Oh, 1 is here, so this is from 5, 6, and 7. 7 is not available, there's already 1 here. So in this column, we know that 3 and 4 are in those cells. So that's not a 3, that's not a 4. This is from 3, 4, and 5. 6 is not possible because that would be 7, that would be 5, and this wouldn't work. 2 is somewhere in here, that's I'm not seeing much. In this column, I still need 4, 5, 6, and 7. So this is from 4, 5, 7. So 1, 5, 6, and 7. And 7 would never work in those cells because no bigger digit is available for those shaded cells. So on this row, 7 is here, that's a 6. Up there I get the 5, that's not 5. And because of this 6, the 6 in this box goes here. So that's 7, that's 5. This is smaller than 5, so this is 3 or 4. And 3, 4, 6 as candidates for those cells. This is from 4, 7, and 8. Now here, oh, there's a 7 down there, so that's the 4. Here I just have a 7, 8 pair. And here a 5, 6 pair. I still need a 2 and a 3 somewhere. They both work in all cells. I still need a 1 somewhere here. So the 1 must be here. And this is from 4. I know that's not an 8 because 8 is there. This is from 4 and 7. Here those are from 1, 5, and 6. The 6 here disappears from the candidates here. I still need a 2 somewhere at the bottom. 2 here wouldn't work because I don't have 2 1s, so 2 is here. So those are smaller than 6 and even smaller than 5. Those are from 1, 2, 3, 4. And I will pencil mark 1, 2, 3, 4 to remind me that I need to put the 6 somewhere in the column. Here would work, here would work as well. Where is the next place of interest? Is it 6 in this box? It could be. 6 would work here. It would work here. It would work here. It could still work there, I think. So that's not a very interesting thing to look. This is smaller than that, so it must be from 1 and 4. I know that this or that is a 7. Oh, and 7 can't go anywhere here next to 5 or 6. So 7 in this box is here. That's 8 and 7 at the top, so 8 goes there. This is a 1, 4 pair. And here that's a 2, 3 pair. Now I get a 1, 2, 3, 4 quadruple in here. And the remaining digits must be 5, 6, and 7. And actually on this row, because of this 7, can only be here. And because of this 7, this is true for another reason. Now that I'm seeing that, this must be from 5 and 6. So I get a 5, 6 pair in this column. I can remove this 5. This is from 3 and 4. And I get the second 1, 2, 3, 4 quadruple in here. This must be from 5 and 6. This is harder than in my memory, to be honest. Perhaps I'm missing easy eliminations. This is totally something I could do. Well, could 3 work in here? And the answer is no, because I would need 1 and 2 here, and it would contradict this pencil locks. And the same is true in this position. If I put a 3 here, then I did 1 and 2 here, and this prevents that from happening. So the 3 can only go there, so that's a 7, that's a 4, that's a 6, that's 7, that's 5, that's 6, 5 and 6 there, 5 there. So that is unlocking all of a sudden. And this is 5. At the bottom I need 2, 3 and 4, so this is 3 or 4, and that has to be the 1. And because of the 6, that's not 6, and this has to be the 6. 3, 4, 5 in here, so that's the 5. 3 or 4 here. I get a 3, 4 pair here, so that's a 1. That's a 4. In this central region, the 6 can only be here, and that here is a 7. So how am I finishing this? This is a 2. So in this column, I still need 3 or 4 here, but because of this, because of the fortress rule, this has to be the 3, the 4, the 2, and the rest should be standard Sudoku eliminations. That's correct. A 1 here, a 2 there, a 1 there, 4 here, 3 and 4. So this is definitely a difficult puzzle, and the 87 points are, well, they are well deserved, I think. I just wish I had been able to solve it correctly without making mistakes during the contest. But this is entirely my fault and not the author's fault. The author provided a very good-looking Sudoku with this visual theme that is really impressive, and the logic is immaculate, I must say. Thanks for watching this video, and see you soon on SudoKanard.